In example 9, of course, the last one in this chapter and in the entire unit, we are told that boxes of chocolates are produced with a mean weight of 510. The mean weight is 510. Quality control checks show that 1% of boxes are rejected because their weight is less than 485. We are told that 1% is below 485 grams. What do we need to know? Of course, weight is distributed normally within 510 grams and standard deviation that is not known. Having said that, we must also understand that the probability of a weight less than 485 grams, of course, we are told those which are below 485 grams are 1%. But of course, normal distribution does not deal with percentage. It knows or it deals with probability. But what is 1% in decimal form? Of course, this is 0.01. Fine. What does that mean? That means that we have to have a model, something which is less than 485, and we have to have a z. Of course, we are going to have a z out of this because our unfamiliar boundary is 485, which is going to give us the z from the table. But I want us to look at this, that the area is 0.01, very small, and it is to the left. So our z is going to be on the left. So this region is the one which is 0.01. And it's incidentally, it must be negative. You must note it is to the left of 0. But by symmetry, we have to have another z here, which is 0.01, whose region is also equals to 0.01. And therefore, the probability of z greater than small z, which is going to give us 0.01, we have to have our z. And what is that z? And because this one looks very conspicuous, we just go directly to the percentage table. 0.01, yes, we have it. And the z, the boundary rather, is 2.3263. So our z is 2.3263. But remember, the purpose of this model here is to show us that whatever z is going to be negative. So negative 2.3263. But how is z realized? We have unfamiliar boundary there, meaning that for z is given by 485 minus the mean 510 everything over the standard deviation, which we don't know. This must give us minus 2.3263. And let us see, what is mu? Of course, 485 minus 510 is negative 25 over the standard deviation, not mu rather. Over the standard deviation is going to give us minus 2.3263. And if we want to make the standard deviation, the subject for the formula is going to have 25 negative over negative 2.3263, which is 25 divided by 2.3263, which is basically 10.74, or rather 10.75, or we can even say 10.7 to 3 significant figures. There we are, having found our standard deviation. Let's see what else we need. Part B of the question is asking us, hence find the proportion of boxes that weigh more than 525 grams. Hence find the proportion of boxes that weigh more than 525. So we want to get the probability of boxes which weigh more than 525 grams. And of course, 525 is unfamiliar boundary. So we need to create a familiar boundary. And we're simply talking about the probability of Z greater than 525 minus 510 over now the standard deviation, which we have found 10.7, 10.7, and then we are supposed to get that proportion. But what is our small z? So this arrangement is supposed to give us our boundary, which is our small z, and let us simply find it. So 525 minus 510, which is 15, you divide by 10.7, it's going to give you around 1.4. Around 1.40. So our small z here, or rather our boundary, is 1.402. 1.402. If this is our boundary, then we're going to look at the probability of a region Z greater than 1.40, because from the table we may not have to this accuracy. And that is just what we are talking about. But from what we know and the way we have been used to working out these questions, it is important to have a model that talks of 1.4, and this is the region we are looking for. This is the area we are looking for. Fine. And this area, the probability of Z greater than 1.4 plus the probability of Z less than 1.4, giving us 1. And this region plus this region is 1. And we want to get this region. We must talk about the probability of Z greater than 1.4 to be equals to 1 minus the probability of Z less than 1.4. The reason why we have to have less than is so that we can go directly to the table, which is going to give us the probability of when Z is less than 1.4. And let's go to simply page 210. When small z is 1.4, then what is the area? 1.4, 0.9192. 0.9192. So the probability that we have Z, the probability that we have Z greater than 1.4 is 1 minus 0.9192. And this gives us, of course, 0.08. 0.08. So the probability that we're going to have boxes that weigh more than 525 grams is 0.08. And that is our final submission. Fine, we have come to the end of this topic, normal distribution. It's quite an important topic. I agree with it, and of course, as you revise, please make sure you understand it. But as I've always said, in case of any challenge, don't be afraid of contacting me. All right?